This is the summary of chemical properties of an alkaline earth metals, that is hydrides, oxides, hydroxides, halides, that is mainly chlorides. Next, all these are depends upon these relations. Size of cation is inversely proportional to polarizing power. More is the polarizing power, more is the covalent character. Next, the size of cation is inversely proportional to acidic nature. More is the size, less is the acidic, less is the electronegativity, less is the hydration energy. Next, size of cation is directly proportional to ionic nature, basic nature and electropositivity. That beryllium oxide is amphoteric in nature. Next, solubility. Solubility is mainly depends on two factors. One is hydration energy, another one is lattice energy. Hydration energy is more, then lattice energy, solubility is what increases. Hydration energy is less than lattice energy, solubility is what going to be what decreases. Now in this video, a very important topic of this chapter, which is asking frequently questions in objective mode. This is salts of oxoacids of an alkaline earth metals. What are the salts of oxoacids of an alkaline earth metals? Means metal carbonates, bicarbonates, sulfates, nitrates. Next, what will be happen? In metal carbonates, from beryllium to barium, thermal stability increases. Same way, in case of bicarbonates also, from beryllium to barium, thermal stability increases from top to bottom. Top to bottom, thermal stability is what increases. Similarly, metal nitrates, top to bottom, thermal stability is what increases from beryllium to barium. Next, what about their solubilities? Carbonates solubility, from beryllium to beryllium carbonate to barium carbonate, their solubility decreases. Same way, bicarbonates also, thermal stability is what decreases from beryllium to barium. Sulfates also decreases from beryllium to barium. Top to bottom, solubility is what? Solubility of these oxoacids is what decreases, thermal stability increases. Next, another important thing is action of heat. Carbonates on heating, it will give oxides, carbon dioxide gas. Bicarbonates, carbonates, carbon dioxide, water. Sulfates, metal oxides, sulfur trioxide gas. Metal nitrates, they will give metal oxides and NO2 gas and O2 gas, half O2. This NO2 gas color is reddish brown color gas. This is colorless gas. Now here, thermal stability and solubility mainly depends upon this what? Lattice energy and hydration energy. Now, what is meant by lattice energy and hydration energy? So now this is the lattice energy. What is meant by lattice energy? The energy required to separate 1 mole of solid ionic compound into its gaseous ions is called as a lattice energy. Lattice energy is called as what? Energy required. So now when we are taking an NaCl, which is present in solid state, by gaining the energy, it is converting into what? Gaseous ions. Here some amount of energy is required. That energy is called as what? 770. That be called as what? A lattice energy. Now mainly this lattice energy is represented by the symbol is U. Lattice energy is directly proportional to product of charge of cation and anion. Here N means 1, 2, 3 and so on we can write. Lattice energy is directly proportional to charge of cation and anion. Cation and anion. Next, lattice energy is inversely proportional to radius of cation, radius of an anion. Okay, now for example, I am taking the dot NaCl. For example, I am taking the dot NaCl. Now NaCl means what? It is Na plus 1 plus Cl minus. Now this is the charge of cation, this is the charge of anion, that is this one, this one. Next, radius of cation or radius of anion. Now sodium ion is having some radius, no? That is here, and chloride ion is having some radius, no, that we are substituting here. Lattice energy is directly proportional to product of charge of cation and anion and inversely proportional to sum of radius of cation and anion. More is the radius of cation and anion, less is the lattice energy. Charge of the cation and anion is increases, lattice energy is what? Increases. Okay, now this is about that what? And lattice energy. More is the lattice energy, more is the melting point of that alkaline earth metals. Next, what is meant by hydration energy? It is the amount of energy released when 1 mole of gaseous ions combining with water and form an hydrated ions is called as a what? An hydration energy. For example, now I am taking that what? Metal ion. Any metal ion you can take, sodium ion, potassium ion, calcium ion, magnesium ion, any ion we are taking which is present in solid state. We are adding that what? Water. Then it is converting into what? That M plus ion is present in that what? And gaseous state. Whenever this metal ion is dissolved in water, some amount of energy is liberated. That energy is called as a what? Hydration enthalpy or hydration energy. Same way, when we are taking the anion, see now this is the chloride anion. Chloride anion is dissolved in the water, it will form as what? An aqueous ion. During this dissolution, some amount of energy is liberated. That energy is called as a what? Hydration energy. So now for example, I am taking that what? Na plus. Whenever Na plus is dissolved in the water, then it will form like this. Now this is the water molecule. Now this is the water molecule. Now this water molecule oxygen is having that what? Negative charge. This sodium ion is having that what? Positive charge. Between this positive charge and oxygen of water molecule, some interaction is taken places. Due to that interactions, some amount of energy is what? Liberated. That liberated energy is called as what? An hydration energy. Okay, now here due to interactions between positive and negative, some amount of energy is liberated. That is called as what? Hydration energy. Higher the hydration energy of ion, more is the solubility. More is the hydration energy, more is the solubility. Now hydration energy is inversely proportional to size of cation, and if it is more hydrated, more is the radius, less is the mobility, and less is that what? Conductivity. That means top to bottom hydration energy is what? Decreases. Hydration energy is decreases means hydrated radius is decreases. When hydrated radius is decreases, mobility is decreases, conductivity is what? Increases. So therefore in aqueous state, what we are telling when we are taking that what? Beryllium in aqueous medium, next magnesium in aqueous medium, next calcium in aqueous medium, and strontium in aqueous medium, and barium in aqueous medium. Conductivity we are writing like this because it is having less hydration energy, less is the hydrated radius, so therefore more is the mobility, more is the conductivity. Now beryllium is having that what? More hydration energy. Its hydration energy is what? More. So therefore its hydrated radius is also what? Its hydrated radius is also more. Hydrated radius means this is like this. If any metal ion is undergoing hydrated like this, their radius is going to be what? Increases. This is the radius of sodium hydrated ion. Okay, now that is this is. Next, this carbonates or bicarbonates. Thermal stability, solubility is what? Thermal stability is increases from beryllium to barium, but solubility is what? Decreases. Why solubility of this oxosalts of this alkaline earth metals is what? Decreases means because hydration energy is decreases from beryllium to barium. So therefore their solubility is what? Decreases. Actually lattice energy, hydration energy both are decreases, but compared to decreasing in the lattice energy, decreasing of hydration energy is more. So therefore their solubility is what? Decreases. Hydration energy is decreases more. Whenever hydration energy decreases more than the lattice energy, then their solubility is what? Decreases. So therefore all the oxoacids of this alkaline earth metals from top to bottom, beryllium to barium, decreases. Thank you.